know, my friends, just a quick one before we start a new topic on function and mapping. Very interesting, simple topic. Before that, I'll give you a short story. You know, back then in secondary school, there was this class rep or class captain. That guy will always write my name for names of noisemaker. Every day. Emmanuel, sometimes, you know that 2x means 2 times, sometimes 4 times. Every time, the guy, they always write my name. Names of noisemaker, names of, so everybody know. Even sometimes, I will not be in school, the guy will still write my name. I'll ask him why. He said that he knows that anywhere I am, I'll be making noise. But guess what? As God is doing things, last week, I just entered one club. I jammed the guy. Guess what? Who the guy be? The guy is now an hype man. So the guy on mic, now they shout, somebody make some noise. You see, who be the right names of noisemaker then? Now they shout, somebody make some noise. This life, balance. In this class, let's discuss everything about function and mapping. Now, these 2 words are majorly confused. What's function, what's mapping? I won't start with them. Let's see our outline for this class. First, we're going to introduce what is function. We'll go further to talk about what are the terms in function. We'll talk about the operations of functions. Now, let's start with the first guy. What is function? Now, before we talk about function, let's first of all introduce the term relation. What's a relation? I'll start by telling you that a relation is just a set of ordered pairs. Now, this is so confusing. What set of ordered pairs? First, let me give you a mind sense, or let me give you a mental explanation. It means that when we say something is a set of ordered pairs, it means that the thing is not alone. For example, things that are in ordered pairs, for example, rice and beans, they always go together, right? Tea and bread, they are paired. Rice and beans, tea and bread, male and female. Know what you are thinking, bro. Know what you are thinking. When you're in class, maybe you're in that class, or you're among your friends, your gang, they always have, everybody's paired, they have somebody they are paired to. You are the only one that is alone. I'm not talking about you. Those of them that are paired is what we're talking about. So when we talk about relation, it means set up for that pairs. You cannot stand alone, you must be with somebody, you must be paired. Father and mother, boy and girl, rice and beans. Give me a set of other pairs, give me for food. Should I say corn and pear? You know those things, right? You know those things. So those are what you call your other pairs. They are. So a relation is just a set of other pairs. What I call a relation, everybody is set of other. Now let me give you a mental picture. You can see these numbers are in pairs. For every A, there is a B. For 1, there is 3. For 2, there is 6. For 4, there is 8. Nobody standing alone, they are paired. Anytime numbers are paired, we call them a relation. What do we call them? A relation. Let me give you another one. X to Y. You can see 2 is paired to 5, 3 is to 6, 2 is to 8. You know this couple goes now. You're in year 1 already. You are wearing to match. Red, blue. You know those things. God when. So everybody was a set of other pairs. We call them a relation. Now we can also arrange this in a format where we have, let's give it a format now. Let's say we have your A and we have your B. You can see that for every 1, we have 3. For every 2, we have 6. And for every 4, we have 8. You can see this is also another way of pairing. It means that 1 is paired to 3, 2 is paired to 6, 4 is paired to 8. Or I can give you another format. Let's say, for example, I do X and I do Y. And I say, okay, 2 is to 5. And I say 3 is to 6. And I say 4 is to 8. You see, anyhow I do them, you should know that 2 is paired to 8. 3 is paired to 6. And 2 is paired to 5. So the arrow tells you, when we do this, we are relating. What I say, when we do this, we are what? Relate. In relation, we just talk about set of ordered pairs, set of ordered pairs, set of ordered pairs. Everybody close their. What's a relation? A relation is a set of ordered pairs. So everybody, what's a relation? Is a set of ordered pairs. We won't talk about set of ordered pairs, we'll talk about relation. And a relation is just a general term. Okay, let's go for that. What's the relation? Everybody, a relation is a set of ordered pairs. That means no number is seen with number as a word pair. Do you understand? Take note that relation can be in 2 formats. We can have what we call mapping and we can have what we call function. So some people will say, now we can see there are 2 types of relation. So relation can either be mapping or what function. Now, what is the difference between both of them? Please calm down. The difference between your mapping and relation is that when we talk about mapping, a mapping is a relation. Okay, first of all, both of them are relation because both of them are ordered pairs without any rules. So we're not checking whether you are pairing them with your cousin. You know, normally in our tradition, you can't marry your sibling. So, we have not tried to check whether they are related, but we're just saying that nobody should be single, everybody should be paired. That's a relation. So relation is not about, we can ask relations in two formats: pairing without any rule and pairing with a rule. So let's now, first of all, say relation can be in two types. We have mapping, we also have function. Let's talk about mapping first. What's mapping? Mapping is a relation. You see that word first, it's a relation. Why is it a relation? Because they are paired. That associates each element to a given set of domain with more or one element in the second set. Look at it. It means that I can be paired to one number, I can be paired to more numbers. So in mapping is a type of relation, but we don't care the type of pairing. Just calm down, you understand it. First of all, know that it's a relation, but it can be paired to multiple numbers. We don't care. Just pair, don't be single. If you like pair with 5 people, don't care. You are dating Daniel. That same you are dating Sandra, we don't care. But in as far as you live paired. So in mapping is a relation that associates one element to one element of the domain to one or more elements in the second set or range. One guy is paired to one or more. It's called mapping. You can see that in mapping, we don't care. We just want it to be what to be paired. So we still give that set of numbers. If you check, okay, 1, 3. That 1 is paired to 3. 2 is paired to 6. 4 is paired to 8. It's not repeating, right? Because all of them are 1 is paired to 3. Now let's see another number like this. This is 2 is to 5. 2 is dating 5. 3 is dating 6. That same 2 that is dating 5 is dating 8. 2 is dating 5. That same 2 is dating 8. In mapping, we don't care. In as far as you are paired. So if you like, date as many people as you want to date. Some of you are datists. Do you understand? So that's one thing about mapping, and we can still do that again in number 1, 2. You can see the numbers just the way we did before in your relation. That's why we said every relation is in mapping. Do you get what I'm trying to say? But just that the general term for all of them is relation, because in mapping you are relating, in function you also are relating. But in mapping, mapping is relating without rules, but function, that's where the problem is. So do you understand what mapping is? Mapping is a relation that has to do with more than one set of elements. You that you are paired. See, 2 is paired to 5 in this one that we'll talk about. So this is a mapping, this is a mapping. But you can see that there's one between number 1 and number 2. Number 1, no number is repeating. Number 2, they are repeating. Now, let's now go to what we call your word function. Are you following this class? Let's go to function. What's function? In function, we don't do anyhow. If you do anyhow, you will see anyhow. You feel me? Right, that. I'm a bad guy, needle. You feel me? Now, what do we do in function? First, let's say that there are 5 boys in the room. Please follow my story. And let's say in your hostel, you are a student. Of course, everybody here is a student. So you're in the hostel, and let's say you stay in the hostel. And, you know, the rule of the hostel is that don't use hot plates. You know what's hot plate? I mean, that hot plate I used to use and boil beans. But why? Because students are vulnerable. So it may be that that hot plate may be earned, and you snip off and you burn down the hostel. So these 5 boys are in the room. School say don't use hot plates, don't use hot plates, don't use hot plates. One of them, let's see, Joseph, stubbornly brought hot plates to the room. And he was boiling beans. And he slept off. And the hot plate exploded and burned your room. So the school went to do road check. Who are the students in that room? Bring all of them. Let's bring all the students.
Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app. And then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester you must do well. And let's proceed quickly as we mark down to our class and continue our class. Enjoy.
Let's say the students, let's list all the students. Let's say number 1, we have Joseph, we have Daniel, we have John, we have Peter, and 5 boys in the room. So these are the boys that burn down the room. Idiot, why did you burn down the room? In fact, bring your parents. So they will ask to come with their parents. See Mr. A, Mr. B, Mr. C, Mr. D, Mr. E. Now look at it. We just brought, the parents are standing this way. The parents are standing this way. And their sons that burn the room are standing this way. So we have not paired them. So you don't know whose father is Joseph, who is the father of Daniel, who is the father. Now, let's say we now start to do pairing now. I now start to pair them. Look at it. You can see that from here that who is the father of Joseph? The father of Joseph is Mr. C. Who is the father of Daniel? The father of Daniel is Mr. A. Who is the father of John? The father of John is Mr. B. Who is the father of Peter? The father of Peter is Mr. D. And who is the father of Emmanuel? Mr. What? E. Now, this is where it comes. Let me ask you a simple question. Is it possible for one man to have 2 sons in that room? Yes. It's possible that Mr. A can be the father of Daniel, can also be the father of Joseph. It's possible. Even if we're not pairing it, it's possible. So it's possible for one guy to be paired to these guys. So for one guy here to be paired to 2 in this part. But listen to me. It's never, so it's possible for one man to have 2 sons. But let me ask you, is it possible for a son now to have 2 fathers? Let's say that Joseph said that his father is Mr. A, and that same Joseph said his father is Mr. C. No. So it's possible for one man to have 2 sons, but it's never possible for one son to have 2 fathers. That brings me to the question now. How many of you know your father? I mean, your real father. Because some of you have gate man tendencies. You just observe that you used to get angry and your gate man get angry, start asking questions. You used to observe that when you're cooking, your house used to sleep, you used to fold his hand, and when you are sleeping, you used to fold your hand, start asking questions. So it's possible for one man to have 2 sons, but it's never possible for one son to have 2 fathers. That's where function comes. What do we check in function? Note that in function, no 2 domain, no 2 sets of numbers must have same domain. Now I'm going to explain that. What do we mean? This part is called a domain. What do I call this part? Domain. So we are introducing something now. This part is called your codomain. In function, it is possible for you to have, it is possible for one codomain to be paired to 2 domains. Because we said that one man can have 2 sons, but it is not possible for one domain to be paired to 2 codomains. That's how we said no 2 sets must have same codomain. So that's our main thing. No 2 sets must have codomain. You can't say Joseph is paired to Mr. C and that same Joseph is paired to Mr. A. So what do we check in a function? We check the domain. If the domain is repeating, it's not a function. Do you understand that? Now let's now define a function. What's a function? A function A to B is a rule of correspondence, that's a relation, which associates each element in A with exactly one element in B. Listen to me, this question has been asked 10 times. A function A to B is a rule of correspondence which associates each element in A with exactly one element in B. Each element in A with exactly one element. You are not permitted to have 2 girlfriends, only one. You can't have 2 fathers, only one father. It's a rule of correspondence which associates each element in A with exactly one element in B. It's a rule of correspondence which associates each element in A with exactly one element in B. It's a rule of correspondence which associates each element in A with exactly one element in B. It's a rule of correspondence which associates each element in A with exactly one element of B. It's a rule of correspondence which associates each element in A with exactly one element in B. Focus! Focus! Look at it. Understand it. Know it. A function A to B is a rule of correspondence which associates each element in A with exactly one element in B. Now let's go check that. Let's say, for example, is this a function? First, let's check. Is this a function? Is this a relation? Yes, because it's paired. Is it a mapping? Yes, mapping to is paired. Is it a function? Let's check. Is anybody having, let's check. 1 is paired to 3. 2 is paired to 6. 4 is paired to 8. Is the domain, you know the domain are the x values, are the a values. Is any domain repeating? No. Because no domain is repeating, we say it's a function. We say what? It's a function. Let's take another one because no domain is repeating. Let's take another guy. We have x is 2 to 5, 3 to 6. Now let's see. What are the domain there? The domain are the x values. That's 2, 3, and 2. Is the domain repeating? There is 2 here. There is also 2 here. That's 2 has a girlfriend in anatomy. That same 2 has a girlfriend in nursing. This is not a function. Why is it not a function? No 2x element must repeat. No 2x element must repeat. No 2x element must repeat. Let's see. Is this a function? Check. 2, 4, 3, 8, 6, 13 is a function. Because no 2s element are what? Repeating. Or no 2b element are repeating. Because here is b to c. Let's see this. We have 1, 2, okay. 0 minus 4, okay. 2, 5. Now, listen to me. We don't care about the codomain. What we care is the domain. Is any domain repeating? Now, let's check. I know you'll be saying, now, these 2, we don't have any business with this 2 and this 2, or 2. We don't have business with the codomain. We don't have business with the domain. Now, there is 1 there, right? There is 0. There's 2, 1 there. But now we have 1 and minus 1. And 1 and minus 1 are the same. 1 and minus 1 are not same. Because 2 people can be same name, but they're not same person. I wish here was just 1. It should have not been a function. But 1 is not repeating. Even if you say this one is repeating, it's minus 1. The difference between minus 1 and 1. So this is a what? A function. I wish it was 1, 2. Let me write that way. 1, 2. 0, minus 4. 2, 5. 1, minus 2. I wish this one is here, 1 is here. It's not, I would have cancelled it. You say I'm not checking whether there is 2 here and there is 2 here. No, what we are concerned is the domains. That is the definition of a function. What's a function, everybody? A function A to B is a rule of correspondence which associates each element in A with exactly one element in B. Hope you now know the difference between a relation, a mapping, and a function. Let me ask you a question. Is it true that all functions are relations? Or, okay, all functions are mapping, but all mappings are not function? Is that statement correct? Look at it again. All functions are mapping, but not all mapping are function. That statement is very correct. Because all functions are mapping. They were first in mapping before they became a function. But not all mapping, because in function, we are checking the x value, they must not repeat. If the sibling must not marry his brother, or one guy should not date 2 girls. But in mapping, date as many, we don't care. So all functions are mapping, but not all mappings are function. Like, you see it. I'll see you in my next class. Like, Dow. I hope you understand the class. Watch it over and again. I see my mom was FSIM. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.